Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to learn how to traverse trees. There are two primary ways to traverse trees or walk through the nodes, and that's depth-first search and breadth-first search. With depth-first search, you walk down and you go deep in the graph where you follow each path before continuing on to the next path. With breadth-first search, you walk across each level, so you would go left to right before going deeper into the graph. So let's visualize that now. So you can see depth-first search follows each path, whereas breadth-first search goes across each level. And there's a GIF of this in the article, so you can watch it and repeat and really understand what's going on. So depth-first search goes deep before it goes wide. You're going to reach the end or the leaves before going across. Typically, we assume depth-first search is better with memory because trees are often wider than they are deep. And the key to implementing depth-first search is using a stack. This can be a stack data structure or a call stack where you implement it recursively. With breadth-first search, we go wide. We use breadth-first search when we want to find the shortest path to a node. And we implement it using queues. In tree interview questions, depth-first search is very often what we use. It is actually somewhat uncommon to use breadth-first search with trees, and it's more used in graphs. So when we implement depth-first search, there are actually three ways to do it, and that's called in-order traversal, pre-order traversal, and post-order traversal. The implementation of these three functions is going to be nearly identical. The only difference is going to be when you use the data of the current node. And the term we use for using data is visiting that node. And when we traverse, we're going to be using a binary tree. So nodes can only have a left or a right child. In our case, when we visit the node or use its data, we're just going to print it out to understand what it is. But in interviews, how you use it is just going to depend on how you're trying to solve the question. And now, let's compare these methods broadly before we go into them individually. Here, we're implementing the traversals using recursion. Although it can be done using iteration, it's easier to understand the logic recursively. And also, you'll get experience with the iterative implementations when working through the course. So each function takes a node, and then we traverse left and right, and also visit the current node. We continue to recurse until we hit the leaf node. So once we hit a null value, then we simply pass this if statement and the recursion stops. The only difference between the three methods is actually when we call the visit node function. With in order, we visit the left subtree, then we visit the current node, and then we traverse right. With pre-order traversal, we use the current node's data, then we traverse left, and then we traverse right. So with pre-order traversal, we utilize the data before going deeper into the tree and deeper into our recursion. Then with post-order traversal, you actually traverse left and right first, so you go deeper into the graph, and then you use the current node's data after your recursion returns. So you use it on the way back up. So in this case, you want to know the results from the lower part or the deeper part of the tree before using the current node's data. And all of these are still depth-first search. They're still going deep before going wide, but the only difference is when they actually use the data of each node. So the first one we're going to look at is in-order traversal, and this prints the items in order. And by in order, we mean as if it were a binary tree and sorted, you would get each item in ascending order. And the way it works is you visit a left path before visiting the current node, and then you visit the right path after the current node. So this is all it is. In code, it's just recursively visit the left path, then you visit the middle node or the current node's data, and then you go down the right path. And we do this for every subtree. So if we start at A, we go left. Now we're at B, well, we go left again. This has no more children, so we visit this node. Now we return here, and we call visit node on B, and then we traverse right. Once these are done, this subtree is finished, and we move back to A. We call visit node on A here, and then we go right. So in order traversal right. And let's watch that in action now. So we start with A, we go down to B, and then we hit C. We visit C, visit B, then go down to D, visit that, then we visit A, then traverse right. We visit E before F because it's the middle node or the current node, and then we traverse right. And the key to remember with in-order traversal is we do as the name says. We want the nodes in order, and you can think of in order as being if you had a binary search tree, it's going to print all the nodes in ascending order. And we can see that now. Here's the same tree construction, but with numbers in sorted order instead of letters. So we start with the middle node, then we would go left, then we have another left path, so we go left here. There are no more children, so we print the current node, then we return and print the current node again, so we go 1, 2, then we traverse right, and we hit 3. Once this subtree is done, we return to the middle, and we have 4 again. It's the middle node or the current node, so we visit that and then go right. So it would be 1, 2, 3, 4, 5, 6. By using in-order traversal, it prints the entire tree in ascending order. The next one to consider is pre-order traversal, and what this does is it visits the current node before visiting any children. So here, we would visit A first and then go left. Then we would visit B and then go left. Then we would hit C and then return here. Then we go right, and so on. It goes middle node, or what I would call the current node, then you visit the left child and then the right child. So it goes A, B, C, then D, and then we go to the right subtree and it prints E and F. And the time you would want to use pre-order traversal is when you want to make a copy of a tree. And the final traversal method for depth-first search is post-order traversal. And what it does is it visits the children before visiting the current node. And what this does is if you have information deep in the tree that you want to recursively find and then pull back up to the current node, you would use post-order traversal. So for example, let's say you wanted to find the node that is the parent of both C and D. Well, if you visit left and right first, down here, then when your recursive functions return, you would see it be that it's the parent of both. So here, as we watch it, you visit children first, you get to those leaves first, the end of the paths, and then you return. So actually our middle node or our root node was the last to be visited because we visit down first and then come upwards. Finally, we'll just walk through breadth-first search. As we said, you walk across levels before going further into the graph. So the first node you visit is A, and then you go to the next level. Then you visit B, E, and then finally C, D, and F. So you go across instead of down. And like I said, breadth-first search isn't super common for trees in coding interviews, so we're going to prioritize time and instead just walk through this instead of really coding it out by hand. But if you really want to dig into this code, it's in the article as well. But when we get to the graph section, we'll really dig in deeper to breadth-first search. So our function calls breadth-first search with the root node. We're going to use a queue, and here it's just going to be a dynamic array. We use a while loop, so we continue to iterate as long as our queue has nodes. Then we dequeue, or here, since it's a dynamic array, we just pop it, and then we visit the current node. Then, if there are children, you just enqueue them into the queue. And to see why a queue will visit levels before going deep, let's just check our tree again. So we enqueue A, then we enqueue its children, B and E. Then we dequeue B and enqueue its children, C and D. Then we dequeue E and enqueue its children, F. Then we dequeue, dequeue, dequeue. So because we're using a queue, it's going to visit those closest nodes before going deeper. And that's how you traverse graphs. We have depth-first search and breadth-first search, and then within depth-first search, we have 3 traversal methods: in order, pre-order, and post-order. But the only difference between them is when we visit that node or when we use the node's data. Thanks everyone, and I'll see you in the next lesson.